So, you might be wondering, what's with the music theme in a presentation about medical robotics at a data conference? If you would indulge me, close your eyes. Imagine a lone violinist. You hear clear and precise notes. A pianist joins, adding additional notes. Musicians continue to fill the room, wanting to join in the jam session. At first, the sounds blend together beautifully. But as more and more musicians join, it becomes difficult for the new instrumentalist to hear the first violinist's intent. Newer notes become disconnected, and the jam session becomes chaotic and devolves into a cacophony. The music stops. You hear two taps of a conductor's baton. And now, with the direction from the conductor, a harmonious symphony orchestra begins. Open your eyes. So that journey from solos, or should I say silos, to symphony is the essence of our data journey. And I assume it's like many of yours. In the early stages of our company, data exploration was like the solo violinist, clear and simple. As new members joined and as the company needs grew, without coordination, data management quickly became chaotic. Today, using dbt as our conductor, we are becoming harmonious once again. We're still working on the harmony part, but we're starting to hear the notes line up. Hi, my name is Chris, and this is Brice, and we work for Intuitive Surgical. My journey began in the world of mechanical engineering, but the allure of data drew me in, leading me to my current role as an analytics engineer. Brice's career started in academia as a professor of mathematics specializing in differential geometry. Yet, the industry called out to him, pulling him to join our team as a software engineer. And just as a tidbit, Brice is also a dbt core contributor, which I personally find really cool. So given our unconventional journeys, we hope we can bring some unique perspectives today, and we're thrilled to share our experiences and insights with all of you. Oops. Okay, so to start it off, we'll talk about Intuitive and the robots we build. Next, we'll delve into how dbt plays a role of conductor in our data orchestra. After that, Brice will explore some details of how we've implemented dbt. And finally, we'll wrap up and talk about how we plan to continue to harmonize our data symphony. First, let's introduce Intuitive. Since 1995, Intuitive Surgical has been advancing the medical world by enabling surgeons to provide minimally invasive care using advanced robotic systems. We have been a pioneer in the medical space and continue to deliver better care for patients by reducing pain and recovery time. If you've heard of Da Vinci surgery, robotic surgery, or they did surgery on a grape, that's us. To give you an idea of how this works, think about an operating room like in the show Grey's Anatomy or Scrubs. Typically, you have a patient with their abdomen cut wide open and a surgeon elbow deep doing their work. Instead, when using our robot, surgical teams make 4 tiny incisions in the patient, and they insert our small robotic instruments and a 3D camera into those incisions. The surgeon, a few feet away, is in our surgeon console, which has a 3D visual of the inside of the patient, and they remotely control those robotic instruments. I didn't want to gross anybody out, so you only get to see the grape surgery. And I'll let it just play through. Oh, that was the end of it. Oh, no, it's not. So this is a small sample of the products that we've designed and built. The top left are images of a few generations of our patient-side robots. And the scene on the right is a patient under a robot and a surgeon sitting on the surgeon console looking inside the body performing an operation. The bottom left is a sampling of some of the medical instruments the surgeons can choose from depending on the type of medical procedure they want to perform. The bottom right, did I say right? I meant left. On the bottom right, you see images showcasing the latest offerings from our digital org. These tools mark our initial introduction into sharing robotic data with our surgeons, such as force measurements, kinematics, as well as surgical data such as procedure duration and patterns of tool usage. Prior to these, most of our data was exclusively accessible internally for R&D. Okay, if you would indulge me once again, I'd like to briefly nerd out on some of the things that I personally find super cool about our robots. If you noticed in the previous video, the instruments doing the surgery are crazy precise and smooth. One of the reasons why I think our system is so cool is we can make the robot feel like a natural extension to the surgeons. Their years of surgical experience don't go to waste. From the mechanical engineering perspective, the management of the kinematic chain of motors and encoders is awe-inspiring. We need crazy high resolution encoders and gearboxes to be able to understand what the surgeon would like to do and have the robot duplicate that. This video is playing an example of one of the data streams from a single joint on one of our 4 instruments attached to a giant multi-axis base. This video is only one of our data streams from the laparoscopic stapler. But imagine each motor encoder has a node in a giant structured peer-to-peer network. There's a lot of data that we generate and successfully communicate around the system. It's really cool. Okay, back to our symphony. Now that you know a little bit about what we do, here I'm showing some numbers for additional context. A surgery starts every 17 seconds by one of our over 66,000 trained surgeons using one of our nearly 8,000 systems for a total of over 12 million procedures to date. For this last number of 12,000, I'd like you to think back to the concert we were attending during the intro of the talk. Imagine the sound of that many unique instrumentalists playing out of sync simultaneously. Of course, not everyone at our company is asking for analysis on robotic data, but let's say 10% is. We get quite the variety of data requests. I'm sure most of you can name the person or people that fit into each one of these buckets. Similarly, you probably know that those deep divers aren't consuming the most scrutinized data. Let's call it dirty data. It's actually their jobs to make sure that the data is clean and trustworthy for the next groups. As we move to the right, the term scrutiny naturally becomes related to trust. For us, those users on the right side are executives and business decision makers, but it also includes our customers, the surgeons. They have to be able to trust the data without question, because they will be using it to make decisions directly for the patients. If we get this part wrong, somebody could get hurt. So this is where the medical device regulation implications start to come into play. We'll come back to regulation after a little bit talking about our journey. This slide should also look a bit familiar to you. These are our 2 first soloists. Earlier in our company's history, we only had a few data players. They could ingest data in any way possible and remained in the context of the teams that they were reporting to. Sorry. As foreshadowed in our symphony intro, we brought in new players with different instruments, and things started to get a bit messy. As data consumers started to ask questions across our silos, they started to notice the numbers wouldn't quite line up. They would get different results due to the data soloists having done their analysis in slightly different contexts. I couldn't fit all 12,000 employees on this slide, but I hope it illustrates my point. As we grew larger, chaos ensued. Okay, at this point, you're probably ready for DBT to come in and save the day. But before we get there, let's come back to the medical device regulation. We had spoken briefly about scrutiny, trust, and the weight of the decisions that could be made using this data. Of course, we take this very seriously. Understandably, we shouldn't do it alone. Here I'm showing some logos of some of the regulatory bodies that we interact with to help us safeguard the scrutiny that we apply to our data. The most familiar one is probably the FDA or the Food and Drug Administration. Okay. One of the most common words you will hear around the intuitive office is qualification. Qualification applies to all of our products, including the physical ones, such as our laparoscopic stapler, and to our inward and outward-facing data products. The process of qualification includes a long list of steps, but all of the steps start with write everything down. The motto is, if it's not written down, it didn't happen. The first thing that we do is identify and define a problem someone is having. Don't forget to write that down. Validation is a process where we begin to iterate on solutions for that problem. We build prototypes and we run lots of studies to determine if the thing we built can solve the problem that we've defined. Side note, I'm speaking in terms of the FDA's definition of validation and requirements. Brice will also be speaking about those two terms, but in a more familiar software context, such as in code validation. I digress. After validating a product, we generate a list of requirements. We write down exactly what features are necessary for the product to do what it was validated to do. After we've built and designed an initial product, we complete verification by checking step by step that we have satisfied each requirement we've written down. This process of qualification is an iterative one throughout our design phases and even after the product has been released. Perhaps we figured out that one of our initial assumptions did not include a particular corner case. We'll make changes and restart the qualification cycle before putting the requalified product back into the field. Getting back to why we do all of this. The qualification process is how we maintain scrutiny and trust in our robots and our data. However, in no shape or form is the qualification a fast process. This is where dbt starts to come into play. dbt's modular structure and built-in documentation allows developers to find and focus on exactly what pieces need to be changed. It allows us to minimize the scope of what needs to be requalified. We keep the scrutiny we need without compromising our agility. For example, if we need to make a change in our data model for how we calculate the kinematics of our laparoscopic stapler, dbt makes it easy for us to pinpoint the changes when we need to contain qualification activities to only those changes. I'll let Brice take it from here to deep dive into our implementation of dbt and the CI/CD pipelines that we've built to bring the orchestra together.
Awesome. Thank you so much, Chris. And yes, so let's take a bit of a deeper dive into how we designed this multi-project orchestration. Just to be clear here, I'm not going to show you the dbt mesh or explorer that was showcased in Tuesday's keynote presentation. This is more about how to orchestrate independent dbt project with a standardized framework using dbt core. So first, let's talk about what is the problem we're trying to solve. And essentially, that's offering dbt-as-a-Service to our data teams on a common platform. And we identified some early requirements for this solution. One of the most important ones is user-friendliness, because as we onboard more and more data teams, we want the process to be as seamless and painless as possible. Scalability, of course, is key, as our data stack and our number of teams and projects is expected to grow substantially. Self-driving applies to our developers, but also the maintainers, such as myself, of our infrastructure. So we really want everything to be automated as much as possible. Full stack, what I mean by full stack here is that we're going to deploy a number of tooling around dbt itself, which I'm going to talk about in the next slide. And finally, perhaps in our specific use case, validation might be the most important requirement because of our heavily regulated environment that Chris explains. So beyond these requirements, we're trying to follow a general guiding principle, which is unified yet independent when it comes to our dbt projects. So why unified? For several reasons. Maybe most importantly, having company-wide standards for testing, validating, and so forth our dbt projects, which I'm going to talk more about, but also avoiding code redundancy, for example, through shared libraries, and also having a central point for observability, monitoring, logging, alerting, and documentation, and so forth. On the other hand, why independence? Well, that one's easy. Like, everyone wants independence, right? When you're a developer of a dbt project, you don't want to interfere. You want to be able to develop in your own yard and deploy and test your project independently from other dbt projects. But perhaps even more importantly, our dbt projects will need to be versioned and to be qualified independently without triggering requalifications of other projects. So let's look at this little overview here of our so-called dbt orchestra. So in the center, we have the most important players, which are the dbt project themselves, and also the code base for deploying them and all the other tooling around it. And then we have all these other sections that need to play harmoniously together. So we have our data warehouse, Snowflake in our case, with several isolated environments, which I'll talk about. Airflow is our job scheduler. Slack is our main alerting tool. We have downstream BI tools and applications, and our website for shared documentation and observability dashboards. So note here that, again, at this level as well, we kind of embrace full modularity, which is that in the sense that each of these components can be maintained possibly by independent separate teams and qualified separately. Let's talk a little bit now in a little more detail about our CI/CD pipeline, so our workflow for continuous integration and delivery. We're going to see what that looks like in the next slide, but maybe let me comment on a couple of design requirements again, or design questions that we had to solve. I'm sure some of you, ran into the same questions, such as, do we go for a mono-repo structure or a multi-repo structure? And solving problems like, how do we handle semantic versioning of our projects? How do we handle deployment, testing, and validation? And what about testing and validating the infrastructure as code itself? All right, so let's do a little thought experiment here for one of our dbt developers. So imagine let's imagine that you're a dbt project developer and you're making a change or you're adding a new model to your project. So the first stage, the first step of the workflow is that. So remember, you have in our multi-project design, each project is a separate Git repository. But even before pushing to your repository, you're going to develop and test your code locally if you want to, so by running dbt on your desktop. And so we have an environment in our data warehouse specifically for this purpose of human users running dbt. Once you're satisfied with the changes you made, you're going to push your changes to some branch, some feature branch in your Git repository, and you're going to create a pull request into the main branch. And this will automatically trigger a pipeline, a CI/CD pipeline, whose main purpose will be to test your changes and to kind of vet the changes that you made. And we have a whole battery of tests that are running in here, which I'm going to describe a little bit more in the next slide. But the most important of those tests would be building your modified models in an ephemeral environment, which I called CI test on this slide. If the pipeline passes and all the tests pass, and once your PR is approved by the project owner or your team, then you can merge it into the main branch. And that's perhaps the most important step. Merging into the main branch will generate a semantic version for your code base. So for example, 1.2.7, and it will deploy your dbt project. So that's another CI/CD pipeline. The main purpose of that pipeline is to deploy the project. And so what that means is updating the tables in Snowflake, but also potentially updating the other tooling that I mentioned before, such as the documentation and so forth. Notice, though, that this deployment is not happening in a production environment yet. What happens automatically is a deployment in this dev environment. And the way our workflow works is that promoting your semantic version to other environments is going to be a manual decision, and it needs to be approved by a project owner, possibly after additional testing. So typically you might have a staging environment where you could deploy whichever tag you want, run additional tests, possibly hand it over to a separate team. Maybe there's a quality assurance team who's separate and independent from your dev team and whose purpose is to test the changes that you made in the staging environment. And once they approved, maybe you can promote your project, your deployment to the prod environment finally. So these two steps are manual. Let's talk a little bit more about the test that we're running. So again, there's kind of a natural progression of tests that happens in CI/CD. All of the tests are run in the PR pipelines, so before merging, but some of them also run afterwards, as we're going to see. So typically, we'll have some preliminary tests that can include things like linting, coverage, checking data contracts, that kind of thing. Then we implemented a framework for unit testing in dbt. And so what unit testing is, it's at the model level. So each individual model in your dbt project is going to be unit tested separately. And essentially, what a unit test consists in is mocking the parent sources of your model, mocking the upstream models by some seeds. So it's kind of like a golden data source. And then you're going to build your model against those seeds and compare what you obtain to the expected output. So we have this kind of mechanism to test this. Unit tests are extremely important because they make sure that when someone else then makes another update later in the future, they won't break the logic. The unit test makes sure that your logic will be safeguarded. Then we have the deployment tests, which are the most important tests that I mentioned in the previous slide. So this is building your dbt project in a CI environment. I also mentioned potentially there's additional tests running in not a production environment, but something like a staging environment, which is like a pre-prod environment. And there's also tests running in production for monitoring, data quality, and so forth. Note here, I can't go into too much detail, but we really fully leverage the power of dbt and things like the -- defer flag. For cost performance, we do random sampling potentially during the deployment tests, and we can easily switch targets. So dbt makes all of this possible in a really neat and cost-effective way. All right, I want to take a step back to our mission kind of, and like how all of what I'm talking about translates in terms of real-world impact. So it's Chris explained. We make really cool surgical robots, but we also make robots that make our robots. And so we have a massive manufacturing footprint and automated lines that go into building, assembling our instruments, robots, parts, but also performing a lot of testing. And those tests are streamed out in real time, and we're collecting all that data and modeling it so it can be used by our engineers for process control. And this is really important information because decisions are made based on this data model. And so we need to make sure that we thoroughly validate the logic that we use in our data modeling. So for this manufacturing alone, it's really cool that we have all this framework built in with all this functionality, tooling, observability, and so forth, which enables, so I put some kind of vague numbers here, but like we have 2 developers maintaining a dbt project that's fully tested, unit tested, and so forth, and that's enabling literally hundreds of engineers that are producing millions of instruments and parts. The owner of this project, by the way, is our teammate Sonny, who's right here, and I definitely encourage you to talk to him if you want to learn more about our manufacturing data pipeline. He's a great guy to talk to, and he knows a ton about our company. Okay, let's talk a little more about observability now. So we have this observability kind of baked in our framework, which has a documentation part of it. So obviously you want to aggregate the documentation of all our dbt projects in a way that's easy to navigate and so forth. So we're spinning up a website that also contains the user manual, standards, and so forth. We have observability dashboards. I'm going to show you a couple examples in a second. And so we have an alerting system. Let me just say about alerting that if you design an alerting system for your dbt pipelines, you probably want something that's a little nuanced in terms of you don't want to ping all of your developers every time there's a warning of any kind of dbt. So you want to probably fine-tune different classification of tests and that trigger different kinds of alerts depending on the case. So is it hard execution failures that needs to be solved immediately? Is it some kind of data quality problem? Some data is out of range, so maybe this can be aggregated in reports, or are there some SLA misses, so service level agreements in terms of like the performance of the executions. So yeah, let's check out a couple of dashboards real quick. So this is a superset dashboards that relies on the modeling of dbt artifacts. So here you can see data on the dbt executions and statistics on like runtimes and test times and so forth. As you can see, there's this neat filter menu on the left, which allows us, so here you can see all dbt projects in one view, or maybe all dbt projects for one team. Look at, filter by environment, filter by target or such. So we have quite a few dashboards. So this is one tab in one of our dashboards. Here's another tab in another dashboard. So we have a dashboard on Snowflake costs, so the costs in our data warehouse. And so here we have, in this tab, you can see our total cost per dbt project and our the breakdown of those costs into usage types. Yeah.
Are these custom dashboards?
Yeah. I'll actually, let me say something about this to answer your question in a minute. But yeah, we kind of wrote a dbt project that models this data. We definitely borrowed ideas from some people I'm going to give credit to. Yeah, so breakdown of cost per target, per usage type, such as storage, compute, and so forth. Okay, I'm almost through my section. I want to say that we also developed a few instrumental dbt packages internally. I think they're awesome. I don't have time to describe what each one of them does. I hope soon we can share some of them as open source packages, and I think some of them might even make sense to be integrated in dbt core. One example of those packages is UDF, which stands for user-defined functions. It was written by our teammate David, who's right here. And this package makes your UDFs first-class citizens in your dbt project. So it integrates them in the lineage graph. You can have documentation and so forth and so forth. And yeah, so I'll conclude by giving a big shout out to the dbt community, because many of the concepts and that I presented and ideas weren't original concepts. We really built on and borrowed from ideas from the community in the form of various sources. So to answer your question, if I take the cost dashboard as an example, we combined ideas from, so I remember a Coalesce talk 2 years ago by I think Jonathan Talmy and Kevin Chan on how to model Snowflake costs. There's a dbt package that's really cool that's called dbt artifacts, developed by Brooklyn Data that we used to use, and now we do something slightly different. But, and I think there was also a Coalesce talk last year by Ian Whitestone. I think I saw him, he's here this year too, to like how to really finally deep into the details of like how to compute Snowflake costs. And so this is just one example, but I could give credits to other people for, our Slim CI implementation, how we classify dbt tests. This was a talk last year, I think, by Mariah Rogers on like how to distinguish between data validation, code validation tests, and so forth. So yeah, I got a ton of great advice and discussions on the dbt Slack workspace, great interactions with the dbt core team. So it's been a real treat to interact with the dbt community. And I'll hand it back to Chris.
Okay. I'll quickly close us out. So we began today with an analogy, comparing our data organization to a growing symphony orchestra. As companies expand, it's imperative for the soloist to transition into symphony members. For us, dbt plays a role as a conductor, a vital role as a conductor. We delved into the world of intuitive surgical robots, illustrating how our growing base of data users presented challenges as we scaled. Oh, thank you. Given the life-critical nature of surgeries, it's paramount that our data is rigorously vetted using our qualification process before it can inform our decision makers and reach our customers. Brice gave you a glimpse into our dbt instance, showcasing some tools that embody the best of software engineering best practices: modularity, version control, and testing. Our unified yet independent strategy ensures our data teams maintain medical device regulatory standards while remaining agile. As emphasized earlier, our quest for the perfect data symphony continues. Our ongoing efforts aim to onboard more internal soloists and migrate the tools that they developed over the 2 decades of Intuitive's history. We still haven't fully utilized all of DBT's current features, including the use of the extensive DBT utils package that could help us with testing and coverage. We're also looking into better ways to automate our model qualification process. And finally, we'd like to thank DBT and the DBT community for enabling and inspiring us to where we are today. As Brice mentioned, we're exploring the possibility of open sourcing some of our tools and hoping to share back with the DBT community. Thanks for joining us on this journey. I know we're 1 minute over, but if there's questions.
Yep, please go ahead.
I was wondering if you could share any process or practice you have around generating the mock data seeds. That's a place where I've always ended up going, well, I'm just running in prod data because I don't know, like a good way to make a representative data set.
Right. So the question was how do we generate mock data using seeds for unit testing DBT models, right? So yeah, unit testing is something that's not really native to DBT at this point, but you can definitely, write. So we wrote macros and stuff to make it happen. We did something that I guess is one of those don't try it at home thing, which is that we overrode the source and ref, so that when unit test flag is running, it switches. It switches from the actual parent to the mock parent. I mean, you don't have to override source and ref to do this. You can write a separate macro. But
I'll just add to it. Like the way that I think about it is corner cases. You just think of every possible corner case you can think of, put it into a mock data set, and then over time it's just a living document where you find a new corner case, you add a new test. I don't know, Sunny probably has some.
I think the only thing I'd add is like, if you're doing like a select star from this to where this clause is equal to 0, and then in my input data, I put that data equal to 1, and it shouldn't show up in my output C file. And so then I go through all the logic in my query, and I just write one mock test case for each of those items in my query, and I ensure that I also add a row. Should this row show up on the the outside of it? And so then I can generate documentation off of that C file as well. So like, yeah, basically go through the logic in your query, write an input test case, and make sure that output equals to what you expect.
yeah, but yeah, big fan of unit tests. So yeah.
Just a quick question for the platform. You guys use dbt core with an orchestration or dbt cloud?
Yeah, we yeah. No, we use dbt core with GitLab CI/CD and Airflow as a job scheduler. As our needs are growing and like our shared so I mentioned we have a shared documentation, but it's not as well integrated as you would have in dbt cloud with dbt mesh, and so moving to the cloud is something that we consider. But yeah, at this point we've made this infrastructure happen with dbt core only.
Oh, cool. So you are like considering it. So much short. So.
Okay.
I have two questions. The first one, I'm almost doing the same work that you are doing right now. You're ready to get with me. So now for promoting from one environment to another environment, are you using flags on GitLab CI/CD, or which kind of strategy are you using? This is my first question. The second one, if you go in your pipeline about the CI test pipeline, are you running the test in all the dbt packages or just one separate for different parts of the repository? How is it working?
So the first question is like about our Git flow and like how we promote to staging and production. So yeah, we use a tag-based system. So each tag is kind of like a photography of the code base at one point in time, and it's that snapshot that we qualify, that we validate, and then that we promote to staging or production. So it's a similar but slightly different workflow from having branches that represents environments.
And then I guess you use this one like in the image of your Kubernetes pod operator, and then you use this one in all your environment based on the tag? How is it going?
I mean, yeah, the technical details of like how we run, our jobs is something like, Airflow, Kubernetes, AWS, that stuff. But, it's really the -- target that decides what the environment is in the code base. Yeah, it's the same code. Yeah, it's the same code base for different environments because all the targets are in profiles.yaml, and so it's just the -- target argument that changes. And sorry, your other question was?
What about the CI test that you're running?
Right.
Because now you're in a mono repository, right? And you are using
No, sorry, no, we're not in a mono repository. Each dbt project is an isolated.
Okay, but actually the question is saying, but then you're running your test based on your different repository, or like you run the test for all the different packages on all the different. How is working with CI test like?
Right. So the question is like, what's the scope of the test in CI/CD? So it's for the project only. So we don't want to have to retest other projects. The dbt packages, so like the external dependencies, are kind of part of the test because there's dbt deps happening, and we use this concept of slim CI, which is that we only test modified models and their downstream dependencies.
Many.
Okay, so how many dbt projects and how do we manage dependencies? So our number of dbt projects is on the rise. I'd have to look, but like I don't know. Right now it's maybe 20 to 30. I'm not sure how many dbt projects we have, and how do we manage dependencies between them. So this would be one of the things that we don't have access to with dbt core that you would have access to in cloud is cross-project references, and so we can't do this. And so when we do have dependencies between projects, we basically make one march table of one project become a source table for another project. But in that way, the projects are like completely independent.
We lose the lineage for one project from the next.
How do you manage upgrades when you guys, let's say, you want to go to newer version, 20 plus repos?
Can you repeat the question?
How do we manage like upgrading? I'm assuming like from dbt 1.5 to 1.6 or whatever.
So once a dbt project is deployed, and so there's a scheduled job running in production, that part is completely frozen. So we completely containerize our dbt project with dbt itself and the external dependencies. All of this is containerized in the Docker image. So even if we upgrade dbt and CI/CD, it's not going to affect the jobs that are already running in production. But if we move from dbt 1.6 to dbt 1.7, in CI/CD, all of a sudden the next updates of the dbt project will use dbt 1.7. I don't know if that makes sense.
I'm mostly talking about like if you have 25 repos,
Mm-hmm.
you have to push exactly the same change to 25 repos to change this version.
I mean, the repos are completely independent. So
It's
are you
kind
talking?
of up to the project owner to, Brice has put out, okay, we're going to use 1.7 now, and then the project owner. So
They push 25 PRs.
yeah.
You also have a core CI repository as well, right? Like, we're referencing that.
Oh, maybe I misunderstood this. Yeah, something I didn't mention is that the logic for our CI/CD is unified. It's in one place. So we have independent dbt projects, but they all kind of ref the same CI file that applies to all of them.
So we don't have to then update 25 repositories. They have a fixed version on all these repositories, and if they choose to go to a different version of that CI pipeline, then they can progress when they choose to, or they can use the old version of that same CI pipeline. Which
That's
means
right.
a different version of each conflict.
That's right. Yeah. Thanks. Please.
Very quickly, I am curious to know how do you communicate downstream changes from data generators to data consumers if you have like these dependencies, because they're independent repositories. If the project owner decides, okay, let's make a schema change, let's change this data type, how do you communicate downstream dependencies
Right.
and ensure that doesn't break anything?
It's really hard.
So I'll just repeat the question. So the question is, when changes happen or made to our dbt projects, how do we communicate the changes to our downstream data consumers?
We're working on it. I mean, right now it's sort of, we started to try and use the exposures in DBT, but even still, that somebody has to go in and put in an exposure. So it's mostly having to know who our customers are and then manually communicating. I'll publish like a Confluence page of, okay, we're releasing this version, and then point people to it.
We're also exploring the Snowflake integration of the metadata now.
Right. Yeah.
Contracts are also huge.
Yeah.
Right.
I strongly recommend everyone enabling data contracts. 'Cause, like,
Yes.
without that, that problem is even more, it's less trackable even than if you don't have contracts. At least with contracts, you get some sort of guarantee.
Right.
Yeah.
Right. Yeah, I think contracts are key, and not just like the data types, but there needs to be agreements between the DBT project owners and their customers. Like what's the contract in terms of what data is being exposed. But yeah, we definitely don't have a streamlined kind of workflow yet to handle that question.
Will not you like just send at the end of each data execution, for example, a notification like email that's saying, okay, I don't know, Slack or by I don't know, other channel. So okay, the DAG is over. So like after the DBT test run and the DBT run is executed and also the DBT test is over, then you're just sending like a Slack notification or email to all the people to say, okay, your table has been updated. You can start the
Yeah, that's a great idea. Thank you. Yeah, like why don't we automate publishing reports or something and automate alerting our customers, the data customers, for the changes. Yeah, that's something that sounds like we should put in place.
Yeah, sorry if I missed this earlier. How do you handle, or do you worry at all about like circular dependencies or things between projects as they reference each other? Like the data model is consumed into another project, and then it goes to another one, and then you're kind of accidentally creating things
Right.
that are hard to trace and debug.
So yeah, as I said, kind of like the dependencies of projects with each other. So we don't have anything that's like integrated as the DBT mesh concept. And so for us, like each a project can be a source of another project. But as far as your project, that other project is completely external, and it's kind of something that you think as a frozen in time, like a data source that you don't have control over. That's how we've been operating so far. It's not ideal, obviously, because some teams have several projects that they'd like to orchestrate harmoniously. But yeah.
So it's up to the project owners to know what's coming into their project and make sure they're.
Yeah, I think again it's a question about contracts, and DBT offers some aspects of what they call model governance in DBT 1.6 that's included in DBT core, such as like having groups, choosing what models you expose to other projects. You can say teams and so forth. But like, yeah, typically you can imagine a system where like your Marts models are going to be public in production, and like your intermediate and staging models are not going to be exposed. But yeah, you have to trust the other project that the Marts they're exposing does the job they're supposed to.
And one thing to add to that, like one thing I've done is that if there's a project that I'm using, I will add unit tests to the tables that I'm using. So if they ever change those tables, their unit test will fail and the merge request won't go. And I'll be the point of contact on that unit test, which makes it really easy to prevent breaking changes from going through, because you'll get pinged as soon as they break the unit test.
Yes.
That's a great way to handle it in the moment, but that also stops their development flow. Do you guys also establish SLAs with those teams so that humans are thinking about it ahead of time? That helps not block them.
Yeah, that's something we're working. I think right now it does block their PR for the time being, and we haven't found a great solution because that's why mesh is what it is. It is the product that it is, because we do run into those scenarios. But usually it's like our teams are pretty close knit, and so we generally have spec documents and design documents, and everything is validated and verified. So like changes are difficult to make, and they don't come as often. So when they do come, we want to make sure that the testing is there.
Yeah. There is an upside to having completely independent projects, which is, this whole qualification process that we discussed so much. It's more clear cut. But yeah. Thank you all so much for all your questions and everything.